Okay, so since in class today when we discussed the sample test, sample final exam, in my version of the sample final exam, my question number 22 is different from your version of the final sample sample final exam. So I want to use this video recording to discuss the question number 22, just to show you how to solve this kind of question. Another purpose is um, given the setup and the how can we use the information to solve a one equation one unknown system. So this let me first read the setup. The expected return on JK stock is 15.78%, while the expected return on the market is 11.34%. The stock's beta is 1.51. What is the risk-free rate of return? So normally we are given the risk-free rate, the market return or market risk premium, and beta, and we are asked to solve the expected return. So then we can use the CAPM model, CAPM model to do that. But here, actually, the expected return is given, and also beta is given, the market return is given. And what's asking us to do is the risk-free rate. So this is like it's based on the same equation, but now we are solving for different unknowns. So let me just do it in my OneNote. Let me copy this question to my OneNote so we can further talk about how to do this. So first, I think the biggest hurdle, as I mentioned this many times, the biggest hurdle to solve questions in this course is how to use the right framework to analyze a question. So obviously here we can use a CAPM model, CAPM model to solve the question because CAPM model basically gives the expected return on a investment or on an asset as a function of its risk, right? So it's equals the risk-free rate plus beta times the expected return on the market minus the risk-free rate. So as we said, normally the question may give you the risk-free rate, beta, or market return, or sometimes this whole chunk, this difference between market return and risk-free rate, and that is called market risk premium. But now the question actually gives you this expected return on the market, that's 15.78%, and also gives you beta, that's 1.51, and also gives you the expected return on the market, that's 11.34%. What's now unknown is this risk-free rate. But this now becomes a one equation, one unknown, so we can basically solve out this one unknown. So how do we do that? So if I switch the sides, just want to move the unknown to the left hand side to be better able to see this more clearly. So if I do that, RF, now the left hand side becomes RF plus using the distribution rule because I want to combine the terms for RF. I have a RF here and I have a RF here, but it needs to be multiplied by the beta. So plus beta times RF not plus because we have a minus sign, so I need to change this to be minus sign rather than plus. So this is a minus, and then plus, using the distribution rule, beta times expected return on the market, and this equals the left hand. Now the right hand side, the expected return on this security. So now once I combine the terms, this left hand side becomes 1 minus beta times RF equals, moving this to the right hand side, equals E expected return on the security minus beta times the expected return on the market. So now if I divide both sides by this 1 minus beta, I basically solve out RF. So RF equals expected return on the security minus beta times expected return on the market, and then divide this by 1 plus minus beta. So now we can plug in the numbers. Expected return on the security is 15.78%, and beta, that's 1.51, and expected return on the market, that's 11.34%. And then this is the denominator is 1 minus 1.51. So now I need to plug in my calculator. So this basically I solve out 2.63%. That's IF. So our final answer is this free rate is 2.63%. So going back to this, so we should choose E as the correct answer. Alright, so I hope by using this question as an example, I have helped you to better understand how to solve one equation, one unknown system. So that's for the discussion for this question.